So I have another series of information. So this is the natural log, again, of P2 over P1 equals delta H over R times 1 over T1. Sorry. Again, I used the other version of this equation so many times. And then if I'm solving for delta H right there, I'm just moving. This is going to go over here because I'm dividing both sides by that number, by that term. So that's going to go over there. And then I got to get the R on the other side too. Again, that's multiplying both sides by R. I did it in the earlier video where I showed it all. And then I've got 8.314 joules per mole Kelvin. And by the way, if you want to go ahead and like divide it out and make it in terms of kilojoules per mole Kelvin, you can. Natural log. And then my P2 value is that one. P1 is that one. Over. 1 over, here's my T1, 200 Kelvin. Now this time my T2 is 600 Kelvin. Delta H. I'll put that in my calculator. 8.314 times natural log of 100 divided by 10. And then divided by, parentheses, 1 divided by 200. 1 divided by 600. So I've got that all closed up. And again, that number is going to be the joules. So I need to change it out. So I need to divide it by 1,000 because it's going to want it in kilojoules. So 5.743 kilojoules per mole. And then this one right here, it's again solving for the P2 value. Let's see, so ln of P2 over P1 is equal to delta H, and then R times 1 over T1 minus 1 over T2. And then if I'm going to do this all right, it's going to need to be e raised to the both sides so that I get P2 over P1 e raised to the delta H over R times 1 over T1 minus 1 over T2. And then I need this P over on the other side. It needs to make sure it does not show up in the exponent region, so the whole thing times P1. All right, now, and I need to just plug everything in. E raised to the, and I need to have my R and my H, so either my units need to all be in joules or all in kilojoules, 8.314, and then 1 over 200 minus 1 over 600, and then the whole thing times the 10 kPAs, and that is not supposed to be in there. So I'm going to do the thing where I solve for the exponent area first, just because it's easier. It's less parentheses to put in my calculator. Divided by 8.314 times 1 divided by 200 minus 1 divided by 600. Parentheses close, so that's that whole number. And then that whole, oops, clear. I'm doing e raised to the, and then I'm just going to use my second answer function. And then that times 10, and it's going to be a big number. There's a reason it's such a big number, and it's because that's a huge temperature jump right in there. But the pressure 2 is going to be 1673603, and we'd probably round that one to 3 sig figs. So it'd be like 167 and kilopascals.